In this video, I'm going to go through the retired questions from 2019, and we're going to break it down into the non-calc questions so that you have some clear practice and examples for the non-calc section of your assessment. So diving straight into it, question 29 says how many meters to the waterfall, but we are given a sign where we are given a distance in kilometers. So you need to be able to convert between kilometers and meters and millimeters, etc. I'll put a little diagram on screen, which is a little acronym for how to remember this. Or you might simply know that 1 kilometer equals 1,000 meters. Kilo actually means 1,000 in general. So there's a bit of a clue there. So if we want to go from kilometers to meters, we need to times 1,000. So 0.75 times 1,000 will give us our answer. And again, break this down. 0.75 times 1 would be 0.75. 0.75 times 10 would be 7.5. 0.75 times 100 is 75. And then 0.75 times 1,000 will give you 750. So you can see there that I broke it into times 1, times 10, times 100, times 1,000 to try and make things easier for me. You don't have to do it all in one go. Question 30, we're given a scenario of a large school. So we're told there are 1,200 students in a large inner city school. 2/5 of these students speak a language other than English at home. So how many students is this? So we need to find 2/5 of 1,200. So what you could do is you can just say, I need to do 1,200 divided by 5 to get what 1/5 is. And then when you find that answer, you then need to times it by 2 to find 2/5. If that's not particularly clear why, maybe just try and think of it as a rectangle broken into 5 sections. And I'll fill this in for you as we go along. So 1,200 divided by 5. You could do that using some short division if you're not too sure. So 5 into 1 doesn't go. 5 into 12 goes twice. So 2 with a remainder of 2. 5 into 20 goes 4 times. And 5 into 0 doesn't go at all. So that's 240. So 1,200 divided by 5 is 240, which would be 1/5. So every one of these boxes is 240. So this is why I've done this diagram to try and help you out. But we want 2/5. So we want 2 of these. So what we need to do now is we need to do 240 times 2. So we need to do 240 times 2, and that will give us 480. But a shortcut for questions like this is if you remember to divide by the bottom, so divide by 5, and then multiply by the top, so then times 2, you'll get your answer. But hopefully that little visual down the bottom made it a bit clearer of why we do this as well. Question 31, it says a census, which is where you survey everyone, found that there were 146 indigenous languages spoken across Australia. Of these languages, 46 were regularly spoken by between 100 and 1,000 people inclusive, and 16 were regularly spoken by more than 1,000 people. And we want to find out how many indigenous languages were spoken by fewer than 100 people. So quite wordy, this one, in all honesty. But what we're going to do is we're going to focus on the facts that 146 indigenous languages are spoken across Australia. And it says 46 of them were spoken between 100 and 1,000 people inclusive. So in other words, 100 to 1,000, but you include 100 exactly and include 1,000 exactly. 16 were spoken by more than 1,000, so 1,001 and upwards. So if we add them up, 46 plus 16, I'm going to use a column to try and make things clear. 6 plus 6 is 2. I carried a 1. 1, 4, and 1 make 6. So that's 62. But there's quite a lot of languages missing at the moment. We need a difference, and difference is a clue to tell you to subtract. So if you do 146, subtract 62, again, I'm doing it in a column. 6 take 2 is 4. I can't do 4 take 6 without going into negatives. So we borrow a 1 from here and make this 14. 14 take 6 is 8. So 84. I have 84 languages left over, and they must be in this criteria here because that's the only other option that's available. These people, between 100 and 1,000, okay, that's one option. More than 1,000 is another. So the only option left is less than 100, fewer than 100. So our answer to this one is 84. The next question wants us to find a mean, but this time it's given to us in a table. So what you can do is you could write all the numbers separately if you wanted to, because number of goals scored 0 time is 1. Number of goals scored 0 time happens once. Number of goals scored 1 time happens twice. 2 goals is scored 4 times, so you could write 2, 2, 2, 2, but that would take a long time. So the best way to do this is to multiply these numbers together. So if we do 0 lots of 1, that is 0. We do 1 lots of 2, that is 2. If you do 2 lots of 4, that is 8. 3 lots of 1 is 3. 4 lots of 1 is 4. And 5 lots of 1 is 5. So this is the number of goals in total. So I'll put here total goals, okay? And then if you add all these numbers together, so 0 plus 2 plus 8 is 10, plus 3 is 13, plus 4 is 17, plus 5 is 22. So there is a total of 22 goals. And if you add this column here, the frequency column, frequency, how frequent means how often. So if you add them up, you'll find that that is 10. And the reason that that is important is because there are 10 games. So you should find that it is the same. I'm just going to use a different color. It is the same as this number here. Okay. So regardless of what method you use to get to this point, that's up to you. But we want to find the mean number of goals. So we now know there's 22 goals in total, and there was 10 games. So we need to do 22 divided by 10, which equals 2.2. So there was an average, mean is a type of average, of 2.2 goals scored per game, every game. So in this question, we are told that the Australian curriculum is designed for a 40-week school year and 1,600 minutes of instruction time per 5-day week. This was in 2019, at least. It might be different nowadays. And it says, how much instruction time is this per day in a 5-day week? So we've got 1,600 minutes of instruction time per 5-day week. It asks us how much instruction time is this per day in a 5-day week. Actually, this bit here, knowing that there's 40 weeks in the school year, doesn't help us with this question. We just need to take the 1,600 minutes of instruction time a week and divide it by 5 so we can figure out how much that is per day. So we need to do 1,600 divided by 5. Again, I would personally do some short division here. So 5 into 1,600. 5 doesn't fit into 1, so we could put a 0 here or just leave it blank. So we carry the 1 onto the next number. 5 into 16 goes 3 times with a remainder of 1. So 1 goes on the next number again. 5 into 10 is 2. And then 5 into 0, we do need to put the 0 here because there's a difference between 32 and 320. Whereas if I just pop the 0 at the front there, that doesn't make a difference. I've still got 320. So I've got 320 minutes. So just be careful because that's your answer in minutes. So we want to break this into hours and minutes as well. So it's important to know that there are 60 minutes in an hour. If I just use a different color here, if I break 320 into 60 plus 60 plus another 60 and 2 more, so I've got 5 in total, that's 300. And then I've got an extra 20 minutes as well. But the fact that I've got 1, 2, 3, 4, 5 lots of 60 tells me that it's 5 hours and 20 minutes. So your answer is D, 5 hours and 20 minutes. The next question is looking at envelope size. So we've got a large envelope is 266 millimeters wide and 376 millimeters long. What are the dimensions of this envelope expressed in centimeters? So again, this is knowing about conversions. I will put that little acronym again to help you remember. Or if you've got a good memory, you might just know that in order to get from millimeters to centimeter, 1 centimeter equals 10 millimeters. So if I'm going from millimeters to centimeters, I need to divide by 10. So I need to take both my dimensions and divide it by 10. So 266 divided by 10 will tell me how many centimeters the envelope is in width, which is 26.6. And 376 divided by 10 will tell us how long it is in centimeters, which is 37.6. So my answer is C. And again, if you know your conversions off by heart, that's great. If not, use the acronym to help you. Question 5 looks at a data limit. Alex has a monthly data limit of 5 gigabytes for internet access. He has used 2.35 gigabytes of his data so far this month. How much more data can he use before he reaches his monthly limit? So we're trying to find a difference again here, which should tell you that we need to do a subtraction. So we need to do 5, take 2.35. If I put this in a column, it'll be a lot more obvious. But what we've got to be careful of is lining things up. So 5 is a unit when it comes to place value. So is a 2. But then we've got a 0.35. And there's nothing here. So the calculation is going to be a bit tricky unless we put something there. So we could say 5 is the same as 5.00. And when we do the calculation now, it will be a lot easier. Okay, so you can use zeros in your column to make things more doable. And what we do here is we can't do 0 take 5, and we can't borrow from here. So we're going to have to borrow from this place here. We exchange a 1 for a 10 here. And then we're going to exchange again, make that a 9, and put a 10 here. So then we've got 10 take 5 is 5. 9 take 3 is 6, and 4 take 2 is 2. So 2.65 is our answer. You could imagine it without the decimal, if that helps. So imagine you've got 235 and you're trying to get to 500. You would probably be able to tell me it's 265, arguably a bit easier. And then just put your decimal point back in. So it's 2.65. So sometimes I encourage my students to imagine it without the decimal. And then remember, the decimal is like a rock when it comes to addition and subtraction. You just need to put it in the same location as it was originally. And there we go. We've gone through all of the non-calc questions from the retired papers. If you look at the video above, I have a bunch of other non-calc questions which have been taken from places such as NAPLAN, the English equivalent, which is called QTS, and that will help you keep preparing. All the best and good luck for whenever your assessment is.